Good evening. My name's Andy Walker. This is the medieval census problem. I'll give you a little bit of my background so you know where I'm coming from. I've been doing computers for probably about 30 years. I spent 10 years at Google working on Google Maps, Google Search, and ads. Before that, I was at Netscape. And along the way, I've probably been doing something which looks like microservices for about 20 years, give or take. So one of the things which is interesting to me is how there are no new problems under the sun. And I decided to see how far I could go with this particular analogy and started looking for things which happened a long time ago, which would allow us to think about the problems that we run in today with distributed computing. I then had a bet with one of my principal engineers that I couldn't make the medieval census work to describe microservices and distributed computing, which I won, or at least hopefully I won, as you're about to find out now. We're going to start off with a little story. Welcome to Andzania, a progressive kingdom ruled by wise Queen Elizabeth. But they have a problem. They don't really know much about the population, and the Queen realizes pretty early on that if she's going to be able to successfully rule her subjects, she needs information. And it starts off with a single question. How many people are in my castle? This is not a good question. And as any data scientist will tell you, you can't give a precise answer to that question because the number is always changing. And you run into this problem anytime you're trying to represent the real world in a computer system, that it's always going to be slightly out of date. And then you start asking questions like, do you mean the castle? Do you mean people living in the castle? Do you mean people living in the castle grounds? How often do you want to count this? What margin of error are you prepared to deal with? Now, at this point, your first data scientist is employed, and this data scientist says they're going to go off and spend the next 6 months coming up with a perfect way of counting that is mathematically predictable and has the lowest bounds of error possible. This isn't good enough for the Queen, and so instead she hires a product manager who wants a quick answer to be able to start making some sane decisions. These are the first poorly worded requirements that come out of the mouths of somebody in a business function. And what they do is they go around the castle and they start counting people, and they come up with a number. Great, but the number's not particularly useful. So they realize that they'd actually quite like some more information about the people in the castle. And so they need somewhere to store this. So they build a little shed with shelves where they can write information on it. They realize fairly quickly that you need to be able to uniquely identify a person, and the first primary keys are born. You realize quite quickly that a lot of the data is common between people. We all have birthdays, we have shoe sizes, or maybe some people don't. We have an age, we have names, we have addresses, and so structured data is born. The data gets out of date because people are born and people die, and so you have the first stale data, which is a particular problem when you're trying to analyze it, and you have to keep your data up to date. And very quickly, the data becomes useful, and then suddenly lots of people are just going into the shed and writing things on pieces of paper or pulling things out of the shed, and it's a complete mess. And this is what tends to happen with relational databases. Is the relational database becomes so useful that it has hundreds of clients, and suddenly you wind up in a situation where you're not sure who's doing what query to what from where, and you have no way of meaningfully changing the data or its structure. At Google, we had this problem with the ads database where all of Google's ads data was stored in a single MySQL database. And it had about 50,000 clients which were able to access this data. And nobody knew what the clients were. There was no way of testing whether the queries were valid or not. And every time they wanted to do a schema change, they risked breaking an unknown number of these clients. So what wound up happening is schema change tended to be done in non-destructive ways, and therefore it turned into something of a black art where nobody truly knew how to navigate this data. And it became almost impossible to make meaningful changes to it as the business evolved. This led to hiring Ned. Ned is hired to be in charge of the shed because it rhymes, and Ned realizes that he is an abstraction onto the data that has been captured, and as such, Ned 1.0 is the first microservice. Ned very quickly realizes that different users need different levels of his attention. For example, if the Queen asks a question, then he probably wants to answer that fairly quickly. Whereas if one of the beggars from the castle gates asks one of the questions, he probably doesn't have to answer that straight away unless there's nothing pressing. So quality of service starts being born as well. And time progresses, and Ned's doing a good job looking after the shed. Then we have the problem that you have a lot of data there. And now you have a choice of, do you have one all singing, all dancing, single universal data store for everything? Or do you have localized data stores? In this case, Dr. Hoffman has his medical records, but nobody can read his handwriting, and therefore nobody wants him putting information into the shed because only he is able to read it. Therefore, NEDS 2.0 becomes the glue between the population data and the medical data, so that a request through to NED can then be sent on via runner to Dr. Hoffman to answer it, and thereby combine the two requests and get some value out of it. This is one of the reasons that microservices are particularly useful, because what tends to happen in an organization is you get heterogeneous data where you have lots of little islands of data which aren't really well glued together, and the cost of trying to turn it into a single all singing, all dancing data warehouse usually isn't worth it. You also start running into the problem where you have unreliable foreign keys, because the data staleness in one database needs to propagate to another database, and when you refresh it, you have to find a way of keeping it up to date. And therefore, the joins between these systems need to be very clever, because they're operating on inherently unstable data. And then a tragedy happens. Ned becomes ill. And we realized that we need more NEDs. We probably needed more NEDs anyway, as the utility of the population data becomes more apparent to everybody in the kingdom. This is our first production outage. We realized that we need to train more people up to NED's job. We need to load balance requests between them. And when we're making a change to the microservice, we need to train all of the instances or clerks who are going into the shed so that they give consistent answer. Suddenly we have a problem of actually how do we deploy a change to it rather than it all being in one person's head. And how do we actually load balance between multiple instances of the same thing? We are nowhere near the stage of needing a service mesh yet, because this is a group of people in a room who can all talk to each other, and therefore the simplest solution is usually the best. Unfortunately, one of the clerks they hired to help Ned is Crazy Bob, and Crazy Bob has a drinking problem. This means that when Crazy Bob is updating the information or making queries to answer people's questions, he frequently makes mistakes. And once you have a dodgy component in your system, you realize that you need to behave defensively. So you have the first backups of the information. And in fact, what they do is every Sunday they stop taking requests and they close the shed to copy the data and have a backup, so that they have a point to recover to. You start taking logs of requests and responses because you want to understand if your service is broken or part of your service is broken, and you want to be able to debug it so that you can identify where the fault is. In this case, it's Crazy Bob, but if you didn't know that, it would be very hard to investigate the problem. And then you start having things like transaction logs so that you can partially replay information from a known state, and therefore you don't have to go back to the beginning again and start over, which makes the process of recovery a whole lot less painful. Unfortunately, in the kingdom, there is a bad actor, bad Sir Nicholas. And don't ask me where I got this picture from. I just entered bad actor into Google, and this is what came up. And Sir Nicholas wants to undermine the Queen, and he realizes that the data is so powerful in the way the kingdom is being run and the decisions are being made, that if he starts making changes to the data, he can start to affect the course of events in the kingdom. Now we suddenly realize that microservices should not be a joyous unicorn land free-for-all, and that actually we need to have some protections against people going rogue, and particularly people going deliberately rogue. So we start having access control lists. We start validating the data into and out of the shed. We start looking at the overall information in the shed. We have abuse detection of seeing if one of the users of the shed is doing a set of things which looks suspicious. And we start having rate limiting so that one part of our infrastructure can't lock out everybody else by denial of servicing, attacking it with too many requests. Now, this is such a useful thing that wise Queen Elizabeth suddenly realizes that this would be wonderful if it was rolled out to her entire kingdom. This is where we've gone from a single data center to multi-region, and data transfer between the particular regions is done via the Horse 1.0 protocol. Now, Horse 1.0 is not a very good protocol, particularly by modern standards. The latency is very, very high, and it's unreliable because the messengers can get waylaid by bandits or lose their bags or get drunk and forget where they're going. There's lots of things which can go wrong here. We also have more information because we're storing it for the entire country than we can store in a single shed. And we have to move to a multi-shedded database model where we're actually splitting across things based upon where the data is coming from. We have primaries and secondaries for that data, and you start looking at things like read and write affinity becoming an interesting concept where the data tends to be primaried where it is mostly being used. So if you had a service within a town, then that town would be the primary for the data within the town because that's the most frequent write case for it, and then replicate that back to the secondary in the capital city. We start needing to replicate large quantities of data, and we start needing to figure out whether something is out of date with something else. Multi-region is when everything goes horribly, horribly wrong in distributed computing. It's when you cannot know the state of another part of your system, and therefore you have to have the mechanisms in place to handle when it gets disconnected or when things get out of sync with each other. You have to start making decisions around whether the data can be slightly out of date or whether it needs to be perfectly in date before you can make a query. You realize that there's no such thing as in date data because the act of replicating the data across your infrastructure via Horse 1.0 means that you're always going to have an unknown part of your data that you're going to have to live with. And when you're starting to look at very large scale distributed systems and you start talking things like eventual consistency, the reality is you're looking for an answer which is good enough right now, apart from some very specialized cases where there are legal or other trust requirements to make sure the data has to be absolutely up to date. And at that point, you start locally primarying the data to make sure that it's there in a trustworthy form for the user that's accessing it. We then have another problem is that one of the sheds burns down in one of our towns. We now have the problem that a request to that for writing to the data will no longer work because there's no shed to write to. We have the problem of primary and secondary election, and this is where we start to look at service meshes for routing things around it, because when you can't rely on a region being there or a service being there in a particular region, particularly if you're operating under the colossal handicap that is Horse 1.0, then you start to need to make smart routing decisions. And this is where having something which makes sure the request gets through to the thing which needs to handle it becomes of critical importance. Unfortunately, this is where the real problems start. Very quickly, you realize that Horse 1.0 needs to be deprecated. If you're going in Terry Pratchett world, you might come up with a system of semaphores between the cities called the clacks. You realize that it's possible for two people to be writing to the same data at the same time, and this is exacerbated by the latency in making the request from the person writing to the data store. You have too many sheds. It becomes very difficult to process the information. The aforementioned AdsDB for Google, it got sharded once, so it had 2 shards, and then a couple of years later it went to 4 shards. By the time they finally deprecated it, it had 130 shards of data. There was so much information there. That meant if you were going to do a request across the entire ads database, you had to have 130 concurrent connections open, and then the client needed to be doing all of the complexity about joining the merging and filtering the data when it got back from the 130 connections. This led to larger and larger memory footprints. It led to lots of retries because if one connection failed, you had to re-request it from all of them, and eventually this has led to the birth of Spanner. which, by the way, still feels like magic to me. By the way, one of the things we can't replicate in medieval times is Paxos, because that requires very low latency between your data centers to handle the multi-server or multi-region write capability. We need to really look at how we update our data. When we are changing our microservices, we now have to change them over a very wide area. We have to train clocks in the new way of doing things with the new structures. We need to push schema updates, and these things take a long time because they have to ripple through an infrastructure which may or may not be functioning at the time you're trying to do it, and so on and so on and so on. When you get to multi-region, you realize just how hard distributed computing can get. So this has been pretty quick. You can use a story which is completely unrelated to computing to think about how our systems perform today. And one of the problems we have as software engineers is that we tend to develop on localhost, which is almost zero latency, very high throughput in terms of bandwidth, 100% reliable. We just simply don't run into the failure modes that happen in the real world when you're pushing something to production. Google search runs on 30,000+ machines, and understanding which one of those machines has gone wrong, or where the problem is, or where there's a problem in the flow of data propagating indexes around, becomes really quite a headache, if I'm going to be honest. Also, bear in mind that any system you build, if it's any good, it's going to outgrow your original design. You have to make the trade-off between designing something which is good enough now and designing something which you can change later, and therefore you need to minimize the cost of future change. And the way you do this is by investing in clean interfaces up front. Another system I built fairly recently was a personalization and search ranking thing for travel search. And we managed to reduce the interface surface there down to 3 methods that you could call across all of it, which would allow you to build a complete rationalized object graph of travel. And by coming up with a clean interface in advance, we could have messy implementations, but our clients didn't care about it. And if you look at the power of microservices, it's about future-proofing our changes so that we can have messy implementations as long as our interfaces are clean. And part of the real art of doing this is coming up with clean interfaces which stand the test of time. The last thing is, whatever you build is going to be abused. When I was working on Google Maps, I was on the abuse team for Google Maps, and that meant carrying a pager for the people doing things like amusingly changing all of Donald Trump's properties to Dump Tower, which we had to unwind, unfortunately, or more tragically, some pretty horrifying things like people creating fake drug rehab centers to try and lure people into their religious cult. And you need to be thinking about how you protect that across your entire architecture, because people won't necessarily be passing through the credentials from end to end. Therefore, you need to make sane decisions about what's going to happen all across the board. Thank you very much. And I'm going to give Dario the ability to get back on time and ask if anybody's got any questions.
Thank you very much. It's very good. Any questions from anybody?
No.
Oh, sorry. Was I muted? Can you hear me?
I can hear you.
Right. Was I muted? You hear me?
I heard you.
All right, cool.
Well, unless you were saying something really weird, but nothing. This seemed like a perfectly normal end to the thing where people are slightly awkward about asking questions.
Right.
To answer Francis, yes, I will be sharing the slides.
Yeah. I usually share the slides on the Meetup page anyway, together with the recordings. As long as the speakers send them to me. Bit too fast. We're trying to catch up with time, aren't you?
Yes, a little bit. And also I tend to talk quite quickly anyway, particularly when I'm doing online presentations, because it's very hard when you can't see the audience. So you can't judge. There's no ability to leave pauses for laughter because there is no laughter.
I loved when you said that Ned is called Ned because he runs the shed.
Yeah, I was trying to find a way of every slide giving myself something to chuckle about as well.
Right. If there are no more questions, I guess in the end we're finishing early. Yeah, I think that's it. All right. Thank you very much. I'm gonna give well, I guess you can go. I don't know. This online stuff is a bit weird and awkward, isn't it?
Yeah.
Yeah. Thank you very much for your talk.
So Sam's just asked a question: 150 shards. How do you handle it? So what Google wound up doing was Google took the source code to MySQL, both the client and the server, and heavily rewrote all of the network code on both ends of that to handle all of the replication cases and the merging of data on the client side of things. And the reality is you handle it badly because it's just such a flaky, unreliable thing. And the problem there is that the SQL database is so useful in the early days that you just commit everything to it until it just ceases to be useful because you've grown beyond what it can give you anymore. And then you find yourself in a horrible hole where your entire business is running on something which is completely unreliable and is getting more unreliable the more successful your business becomes. And it was that kind of hole which led to the creation of Spanner and having a shardless database which runs across multiple regions, which is pseudo object relational, and which allows you to do concurrent writes effectively. And yeah. So the abuse team I was on was when things went horribly wrong and things upset governments, and we needed to quickly step in and bring lawyers and PR team into it. We were also trying to stop bad data getting onto maps. The reality is any time you're on a very popular computer program and there is the ability for people to make money through bad practice, then people will industrialize the abuse that they bring into your system. And in fact, somebody estimated that fraud on Google Maps was a multi-billion-dollar industry. And they started worrying that the people who were coming from the criminal agencies, or in some cases state actors, were way more resourced than the teams actually trying to stop it happening. And some of the abuse was really quite sophisticated. So load balancing would be once you've got multiple instances of Ned, when Ned's trained up his cohort of clerks. After you realize that when Ned gets sick, you have a completely unreliable system because you have a single point of failure, at which point you might have something like somebody brings in a request written on a piece of paper, they put it in a tray, and then the next available clerk takes the item from the top or bottom of the pile of things, goes off with the query, and then sends the response back to the originating requester.